Hello everyone, I'm Lokesh Mathur from Swanit Education. In the earlier video of clock, that is in part 1, we went through the concept of clock and we also understood how to calculate the angle between the needles when a time is given. In this video, we'll be checking the other side of the question. For example, if we are given an angle between one of the hour, we have to find out at what time that angle is achieved between the minute and the hour hand. So let us understand this in detail because it becomes one of the most commonly asked question in many of the competitive exams. Let us take that question one by one. So when it comes to angle to time, we will be talking about certain questions such as between 2 to 3, when do we have 0 degree, 90 degree and 180-degree angle? So what I'm going to do here in this video is I will explain you the concept first of all, and then we will look at some shortcut method in which we can solve the question probably without using pen and paper. So let us talk about this question in detail. So when we say between 2 to 3, so actually what is the angle when it is 2 o'clock? See, when it is 2 o'clock, this is how the needle looks like, the minute hand and the hour hand. So the angle between them, as we know, between one major dimension, the angle is 30 degree in a clock. So since it is 2 o'clock, the current angle would be 60 degree. Now we are going to look at a time when we have 0 degree first of all, and then we'll talk about 90 and 180 as well. So to get the angle 0 degree, this minute hand must travel to such a distance so that both these needles overlap, and virtually this becomes the situation when both the needles overlap and the angle becomes 0 degree. So let us assume, let the time after which they coincide be t minutes. Let the time be t minutes after which the needles coincide. Now from the previous video, we already know that in a minute, in 1 minute, the minute hand travels 6 degrees. This is the case of a minute hand. Whereas the hour hand travels half a degree in 1 minute. So now let's look at the diagram once again. Let's assume I'm taking a different color so that we understand it better. Let's assume after t minutes the hour hand moves till this position because we are talking about somewhere between 2 to 3, and therefore in t minutes only the minute hand will come at a contradiction, or in fact at a place wherein they both will coincide, which means in t minutes minute hand will travel a total of 6t degree because in 1 minute it travels 6 degrees, whereas the hour hand will travel half a degree for t minutes, and therefore a total angle traveled by the hour hand will be t by 2 degrees. Now as you can see, the angle traveled by the minute hand is 6t, which is the total angle. So therefore it should be equal to the half degree multiplied by t minutes of hour hand as well as the initial angle that was 60 degrees. So as we can see, the equation is formed now. The minute hand travels 6t degrees, hour hand travels t by 2 degrees, and their initial angle was 60 degree. And therefore when we solve this equation and I bring t by 2 on the other side of the equal to sign, and on the other side we have 60 degrees. So when I solve it, I'll be getting 11 by 2 times of t is equal to 60 degrees, and therefore t is equal to 60 multiplied by 2 divided by 11, that is 120 by 11 minutes will give me the answer. So virtually if I look at my answer, it should be between 2 to 3. So it is 2 hours, some minutes and some seconds. So when I divide 120 by 11, I'll be getting 11 ones are 11 and the remainder is 10. So therefore a 10 over here, which gives me 10 minutes. And so this value will give me 10 10 by 11 minutes. Now since I have to calculate the seconds, so I convert this 10 by 11 minutes into seconds by multiplying it with 60, which is giving me 600 by 11. And upon division it gives me 11 fives are 55 and 11 fours are 44. So at 2 hours 10 minutes and 54 seconds I will be getting a 0 degree between the needles. So this is the conventional method of solving the question. For this we had to draw the diagram, then look at the drift and the movement of the needles. Can we do it in a different way, or can we solve the question without the actual conventional process? Yes, let us see the same question once again. Now my initial question was 2 o'clock and hence the position of the needles were 60 degrees apart. Now please understand it carefully. Since the minute hand was traveling 6 degrees in a minute and our hand was traveling half a degree in a minute, so if I calculate their relative speeds, I will come to know that it is 6 minus 1 by 2 and that is equal to 5.5 degree per minute. Therefore, every minute they will travel a distance of 5.5 degree. So when we are talking about an initial distance between them at 2 o'clock is 60 degree. So therefore to coincide with each other, minute hand should have a relative movement of 60 degree at the speed of 5.5 degree per minute. So what we do here is, whenever we are talking about chasing of one object by the other, even in time, speed and distance, we will look into this concept in detail. But like here, minute hand is chasing the hour hand to get contradict or even to get the uh, coinciding segment. So therefore, what we do, we keep the hour hand as constant. We do not move this hour hand at all. We keep it here only. And we move the minute hand with the relative speed instead of its actual speed. So therefore, the actual speed of the minute hand was 6 degrees per minute. But we will rotate or we will move this minute hand with 5.5 degrees per minute. And to cover the total distance of 60 degree with the speed of 5.5 degree per minute, whatever time I need is the time when they will coincide with each other. And if you look at this data, that is 60 divided by 5.5, this is equal to 60 divided by 11 multiplied by 2. So we have directly reached this solution by looking at the concept of relative speed. I will explain it with another example. So now let us talk about a 90-degree segment. So once again, the position of the needles at 2 o'clock is 60 degree apart. Now I want to have 90 degree between them. So look at it. This needle will rotate for 60 degree and therefore it will become 0 degree, and then it will come further for 90 degrees, and hence somewhere over here the needles will come at an angle of 90 degree. As I told earlier, we will not rotate the hour hand at all. We will keep the hour hand at the constant, at the stationary place. It's only the minute hand that will rotate. So it will rotate 60 degree and then 90 degree. So overall movement will be 150 degree at the speed of 5.5 degree per minute, and that's the time I was looking for. So it will give me 300 upon 11 when I remove the decimal and convert 5.5 into 55. So upon solving, it will give me 11 twos are 22, 11 sevens are 77, 3 by 11 minutes. And therefore my answer to this question will become 2 hours 27 minutes, and since it is 3 by 11, so if I have to convert it to seconds, I'll multiply it with 60, which becomes 180 upon 7, which is 7 twos are 14, 4 zeros, 7 fives are 35. So at 2 hours 27 minutes and 25 seconds, we will achieve an angle of 90 degree. So easy without diagram. Let's look at the last one, that is 180 degree quickly. Again, the initial angle between the needles is 60 degree. To get 180 degree, I have to rotate this needle by 60 degree first of all, and then it will rotate further and move to a place wherein this minute hand will become a 180 degree with the hour hand. So overall, the total angle traveled will be 60 plus 180, and that is 240 with the speed of 5.5 degree per minute. 240 upon 5.5 is nothing but, I'm using this space, 480 divided by 11, which will give me 11 fours are 44, 11 threes are 33, and 7 upon 11 minutes. So actually my answer to this question becomes 2 hours 43 minutes, and again to convert 7 by 11 into seconds, I multiply it with 60, which gives me 420 upon 11, which is 11 threes are 33, 90, 11 eights are 88. So 2 hours 43 minutes and 38 seconds, I get my 180 degree between 2 and 3. So I hope instead of the conventional method, this method sounds more quick and more convenient for us to get the answer. Let's look at some more examples from the same category. So now my next question is, between 10 to 11, when do we have 0 degree, 90 degree and 180 degree? Now this time we'll be using the shortcut method that we have understood just now. Now let's suppose this is 10 o'clock. This is how a 10 o'clock looks like. Once again, the beginning is with 60 degree. So first of all, when it will move, when the minute hand will move, it will come at this place and it will be a 90 degree situation. So for it to be 90 degree, it will move another 30 degrees. Now 30 degrees, please understand, 30 degrees with the speed of 5.5 gives me 60 divided by 11. I'm just writing the data first of all, and then we can do the calculations. When this minute hand will move further, it will come exactly opposite and will form a 180 degree angle. So therefore, initial 60 degree, and then it will move for some more degree to get the 180 degree angle. So to make 180 instead of 60, I will have to move 120 degrees apart. 120 degree with 5.5 is equivalent to 240 upon 11. Again, we'll do the calculation a little later on. How about 0? Now please understand, this initial angle was 60 degree. To make it 0, this minute hand has to travel all the way from here and coincide with the hour hand. So therefore it has to travel for all the 300 degrees with the speed of 5.5 to get a 0 degree angle, which is equal to 600 upon 11. Now rest all is calculation and we will get the answer. So let's see, when we are talking about 0 degrees, we are talking about 10 hours, few minutes and few seconds. So when I divide 600 by 11, I'll be getting 5 times 55, then 4 times 11 fours are 44, then the remaining is 6 by 11. To convert it into seconds, I have to multiply it with 60, which becomes 360 upon 11, which is 3. 11 threes are 33 and 2. So that's when I get 0 degrees. How about 90 degrees now? Let's look at 90 degree once again. So it was 60 upon 11. Now since it is 60 upon 11, I'll be getting 10 hours. 60 upon 11 will give me 5 minutes and 5 by 11 seconds. 5 by 11 seconds will, or in fact 5 by 11 minutes. To convert it into seconds, I have to multiply it with 60. So it becomes 300 by 11. So 11 twos are 22 and sevens are 77. Now next one is 180 degree. Let's look at the 180 degree segment. So it was 240 by 11. So 10 hours, 240 by 11, which gives me 11 twos are 22, 11 ones are 11, and the remainder is 9 by 11. Again, to convert it into seconds, I multiply it with 60 to get 540 upon 11, which gives me 11 fours are 44 and 11 nines are 99. So these are the timestamps when the angles between the needles will be 0 degree, 90 degree and 180 degree between 10 and 12 hours. So this is how easy it becomes when it comes to angle to time conversion. Now let's look at some more variety of questions that we get from clocks. Now there are certain standard questions which are being asked. For example, you can see a table on your screen which says in 12 hours, how many times do we have 0 degrees? Similarly, in 12 hours, how many times we have 90 degrees, 180 degrees, and how many times the needles are in straight line. Similarly, the same pattern follows in 24 hours 0 degrees, 24 hours 90 degrees, 24 hours 180 degrees and the straight line. So these are the standard 8 questions which are being asked from the clock segment. Let's try to figure out the answer. Now when I'm talking about 12 hours and 0 degrees, so in 12 hours, if I have to find out how many times do we have 0 degrees, let's figure this out. Let's take an example between 1 o'clock and between 2 o'clock. So between 1 o'clock and 2 o'clock, if you just visualize, this needle will start moving and there will be an instance when both the needles will coincide somewhere here and making an angle of 0 degree. When this needle moves further towards 12 pointer, it will be 2 o'clock and therefore we have 0 degree between one of the hour span, that is between 1 and 2. So therefore it says between or in a duration of 12 hours we'll be getting 12 times of 0 degrees, but that's not true. Actual answer of this question is it will be only 11 times instead of 12. And why? Because if you visualize between 11 to 1 o'clock, between 11 to 1, there is only one time that the needles coincide and that is at 12 o'clock. So this is one exception I will be pointing here, that is at 12 o'clock or between 11 to 1 it happens only once and therefore instead of 12 times it should be 11 times. Now because in 12 hours it is happening 11 times, in 24 hours it will happen 22 times, exactly double of 12 hours situation. Let's talk about 90 degree now. Now between every 2 hours, 2 consecutive hours, we get 2 times a 90 degree. For example, when I talk about 12 o'clock, let's say this is how 12 o'clock is. So once we get a 90 degree somewhere over here when the minute hand reaches here and the hour hand is over here. That is at 12 hours and 16 minutes. Next time, this very needle moves in the opposite direction and minute hand reaches over here whereas hour hand is here and we again get a 90 degree. That means in an hour 90 degree is achieved twice, except for the fact between 2 to 4 it happens only 3 times. See, between 2 to 4 this is the span of 2 hours, so it should happen 4 times, but it happens only 3 times. Similarly, between 8 to 10 it should happen 4 times, but it is happening only 3 times. So therefore in 12 hours, it should happen 24 times, but since there are two exceptions, we achieve a data that is 22 times 90° is achieved in 12 hours. Similarly, in 24 hours, it will become a double data. So it is 44 times. Now 180°. Every hour we achieve 180° once. But again, like the other two categories discussed, this one also has some exception, and that is between 5 to 7 you will have only one 180°, and that is at 6 o'clock. So this is the exceptional situation, and because of which instead of 12 times it is 11 times, and therefore in 24 hours it is 22 times. One final thing, that is straight line. Now please understand, straight line can be a combination of 0 degrees and 180 degrees. That is, needles are said to be in straight line when they form 0° and also straight line when they are in 180° situation. Therefore, the answer of straight line 12 hours will be a combination of these two data. Therefore, it will be 22 times, and over here it will be 22 plus 22, that is 44. Again, the exceptions will lie between 11 to 1 for 0° and between 5 to 7 for 180°. So this table will give a fair idea about the variety of questions that we get from clock and their pattern for 12 and 24 hours. So kindly go through this table carefully, because this question is asked directly in the examinations. So along with the questions based on time to angle, angle to time, these are also standard questions which we get. I hope you have understood all the major concepts based on clock, because now we will be talking about the faulty clocks in the coming videos. I would request you can subscribe to our channel Swanit Education. By clicking on the bell icon, you will get notifications for the newly uploaded videos. In some more videos, we will be discussing all the other segments of aptitude. I hope you have liked and got some sort of benefit with this video. We'll be coming back with another video. Till then, thank you.